Go ahead and just do the first one first. So it is an ellipse. A lot of the ellipse is similar to the hyperbola that we just did. For example, where's your center?
-1, 2.
-1, 2. What does the 9 tell me?
Go to the left or right 3.
Exactly. So 1, 2, 3, 1, 2, 3. How about the 4 under the Y there? Up and down 2. Now when I connect them though, I connect them with a nice little oval. I don't connect them with a box. I find those points exactly the same way, but I connect them with an oval because this is an ellipse. How do I know it's an ellipse? It's a plus sign in the problem. You will also have a guaranteed clue. It talks about major and minor axis in the answer blanks. That's kind of your clue. That's an ellipse. Now, see these 4 points right here that I connected? Those are the vertices. Those have to go in the vertices blank. So what are those? If we counted forward 4, or 3, counted forward 3, this would be 2, 2. -4, 2, -1, 4, and -1, 0. Those are your vertices. You okay with that? Now, this is called the major axis because it's the long one. How long is it?
6.
6, because you went back and forth 3. This is your minor axis. How long is it? 4, because you counted up and down 2. Those should be easy points, because we just count. Now the only thing left is you have to identify your focus points. Now remember, the focus points are always on the long axis. They're always on the major axis. So we're going to be going sideways to get our focus points, which means we're going to be adding and subtracting to the x value, right, if we're going sideways? Now, what are we going to be adding and subtracting? Well, we have to find the distance from the center to the focus. What is it?
√5.
It's √5. Very good. Because in an ellipse, we subtract them. In a hyperbola, we add them. Kind of remember, it's the opposite of the sign in the problem. So we're going to take that √5 and we're going to add it and subtract it to the x coordinate of the center. Why am I doing it to the x? Because my points are sideways, right? If my points were up here, I would add and subtract it to the y.
Wait, how'd you know those points are sideways again?
Because they're always on the long axis, and the long axis is sideways. So what are the coordinates of these 2 points? -1 minus √5, comma 2, and -1 plus √5, comma 2. Start at your center, and in this case, we're going to add and subtract the √5 to the x coordinate because our foci are on the x-axis. Okay? Anybody have a question about that? You want to just go ahead and start number 2 then? In order here? All right, number 2, we've already decided was a parabola. And it's a parabola because only one term is squared. Where is my vertex? We don't call it the center, we call it the vertex. Where is it? 1, -2. Everybody okay with the vertex being at 1, -2? Now, boys and girls, which way does it open?
Right.
Tyler, why do you think it opens right?
Y squared is positive.
I I couldn't have said it better myself. It's y squared and it's positive. And Tyler remembers the rules. And if you don't remember the rules, you better be learning the rules because you got to know them. Y squared, positive 12, opens to the right. Now you can cross off the axis of symmetry blank. Remember, that was my mistake. Our focus is going to be right here, somewhere in there. It's just like with the hyperbola. The focus is inside the curve. This distance right here, anybody remember what we call it?
P.
P. And to get P, we go back to our equation because whatever number is sitting out here is always 4 times P. So if we divide that by 4, P ends up being 3. So we're going to go sideways 3 units. So that would be the point 4, negative 2. Now remember, if you go to the right 3 to get your focus, you're going to go to the left 3 to get your directrix. So when I back up 3, my directrix remembers a line, and it's a line that crosses which axis? So x equals negative 2 is my directrix. From your vertex, which is at 1, back up 3 units, you'd be at negative 2. What's your focal width? 12. The focal width is just this number. This number is the focal width. If that number happens to be negative, what do we need to do? Take the negative off, yeah, because the width has to be positive.
We don't do it.
All right, anybody have a question about one of those things? Remember, you're crossing off the axis of
So the
symmetry.
focus is 4 negative.
Yep. All right, on the back, we're not going to get this done, so you'll finish this for homework. Where's the center? I'm on the back side now, number 3.
2 negative 3.
My center is at 2, negative 3. What do I do next? My center is at 2, negative 3.
So you go left 4, and left and right 4, and up and down 2.
So I'm going to go left and right 4, yep, that's right. And up and down 2. Now, in the problem I did earlier, I did exactly that same thing. I put a center on there, and then I counted sideways and up and down. Then I connected them with an oval. What do I do now? I connect them with a rectangle and make my box. Now what do I have to figure out? Whether it's sideways or up and down?
Sideways.
Since x comes first, it's going to be sideways. So right here on the edge of the box is where I start my hyperbola. And these big, fat, black points are vertices. And I got those by counting sideways 4, right? So this would be 6, negative 3, and negative 2. No, negative 2, negative 3. Sorry about that. 6, negative 3, and negative 2, negative 3. All right, that's it. Here it's over. We're going to ring here any second. So you need to finish the rest of the hyperbola problem for homework. that is your only homework. Tomorrow we will answer last minute questions and then we will take our quiz. Thomas, can you switch us off there? Anybody else that has an exam conflict?